This is a lesson for day one for solving rational functions. We're going to be solving these equations using a method called clearing the fractions. When we clear the fraction, if your equation has rational expressions, which we will, in other words, the fraction, we multiply both sides of the equation by the least common denominator to clear the equation of rational expressions. We did this earlier this year. I mentioned it in the last section. You must use this method to solve these. If you use a different method, you will not receive credit for these. I am going to be assessing you on your ability to use this method specifically to solve rational functions. So let's start with first example. We have two today. We're going to be solving an equation like this. 6 equals 5 over x plus 6 over x squared. Now, in order to clear fractions, we have to identify what the common denominator is. Between x and x squared, the common denominator would be x squared. I don't have to count both because this x squared already includes 1x. So this x is already inside of that, so to speak. So I just need to use x squared. So I'm going to multiply both sides of the equation, or in other words, all three terms by x squared. So we multiply the 6 by x squared, and we multiply the right side by x squared, which means each term is going to be individually multiplied by x squared. You don't need to show both steps. I really just typically show this second step here. I'm taking each term, 1, 2, 3, and I'm multiplying each term by x squared, the common denominator. Now you can see what happens here is that this side, nothing cancels, and it just makes 6x squared. On the right side, this x is going to cancel with one of those. X squared divided by x. 2 x's, take away 1x, leaves you with 1x, or 5x. Here, x squared cancels completely, leaving me with just 6. So we're multiplying by the common denominator with the goal of trying to cancel out denominators. And when you multiply everything by the common denominator, each term by the common denominator, it will eliminate the denominators. And then what we have left is typically a quadratic equation, maybe a cubic. We're not going to do anything too hard though, so we're going to stick mainly with quadratic equations. And so I have this quadratic, simple factor and solve. I'm going to set this equal to 0 by subtracting 5x over and subtracting the 6 over to the left-hand side. Some quick factoring. Factors of 6 are 2 and 3. Factors of 6, 3, and 2 we'll use so that the outside gives me 4 and the inside gives me negative 9. Negative 9 plus 4 is negative 5. So we're just doing some basic factoring there. So now I'm going to use the zero product property. The zero product property says that each factor can be set equal to 0 separately and then solve. So I'm going to set 2x minus 3 equal to 0, add 3, divide by 2, gets 3 halves, or 1.5. Here I'm going to minus 2 and divide by 3, so I get negative 2/3. You must check your solutions. Some of these will be extraneous and they will not work. When you substitute these in, you'll find out that both of these do in fact work. Plug in 3 halves, negative 2/3 into the original. Do not plug it into this. You're going to make sure you plug it into the original. Probably the easiest way to check this is to graph maybe this right-hand side. You can solve this on the Solver app. It's a little bit tougher to solve though on that because you're looking for 2 answers, but if you know how to use the solving app correctly, you can use that. But I would think that it would be a little easier to maybe graph this. So I would graph this right-hand side, both of these together, 5 over x plus 6 over x squared. Make that y1, graph 6 as y2, and then g-solve intersect. You're trying to find where these two are equal. So what you'll end up with basically is a rational function looking thing when you graph it on the calculator. And then that rational function will intersect with 6 at some point in there. 6 will just be a horizontal line at 6, it intersects with that at 2 different points. It should intersect. And then you should be able to check that both of these are solutions because you'll see it intersecting at both points. Okay, we will check that, and we'll do that here in a moment on the calculator. Let's go to the second example. What I have here is an expression that has an x and an x minus 4. Now remember, binomials cannot share terms. So this x is a term. It can't be shared with this x. So I have two separate things, x and x minus 4, because I have to treat that x minus 4 as one whole thing. It's not an x. This is not an x. This is an x minus 4. So I have two different things. So my common denominator is going to consist of both x and x minus 4 since they're very different. So I'm going to multiply everything by the common denominator of x and x minus 4. So we're going to multiply really all three terms. 1 over x by x and x minus 4. 1 over x minus 4 by x and x minus 4. And the 2 by x and x minus 4. So again, all three terms get multiplied by the common denominator of x and x minus 4. I think it's pretty easy to see what cancels. Here the x's would cancel, leaving me x minus 4 times 1 or x minus 4. X minus 4. And then here the x minus 4s are going to cancel, leaving me x times 1 or just x. So I have x minus 4 plus x. And then here I'm going to multiply everything by 2 and x. As I distribute that, I'm going to do 2x times x becomes 2x squared. 2x times negative 4 is negative 8x. So we combine like terms. X plus x makes 2x minus 4. And okay, it's quadratic. We got to get it equal to 0. I'm going to minus 2x over. Negative 8 minus 2 is 10, negative 10. And I'm going to add the 4 over, gives me plus 4. Now this clearly has a GCF of 2, so I'm just going to get rid of the 2. Divide everything by 2. Gives me x, 5, and 2. Now this is not factorable, so we're going to have to pull out quadratic formula, and there's the formula there for you. And when you plug in a, b, and c, you're going to get 5 plus or minus the square root of 17 all over 2. 5 minus the square root of 17 all divided by 2 gives me about 0.44, 2 decimal places is okay. And 5 plus square root of 17 all over 2 is 4.56. And again, we're going to have to check those answers. So we'll go ahead and do that now on the calculator. Let me grab calculator real quick, and we're going to go to the graph app, and we're going to go ahead and graph both of these. I'm going to graph this left side as y1, so I'm going to do 1 over x over x plus 1 over x minus 4 and then as y2, and then as y2 I'm going to put in the right side of the equation, which is just 2. So we'll go ahead and put that in as 2. We got to turn all this other stuff off. And we'll go ahead and graph it. And obviously we're going to need to zoom out a little bit. Alright. Good. Let's make sure we have everything turned on right. Yeah. It's changed my window. I think we're going to need to change the window up here. Oh, we can just zoom up a little bit here. And there we go. We can see it intersecting now. Actually have, as I zoom up a little bit, I can see, yeah, it's intersecting at 2 different spots. Sure looks promising. So we're going to go gsolve, intersect. And I see about 0.438. There you go. And when I press the right arrow, I'll get the other answer, 4.56. So I've confirmed that both of them do work. It is very possible that one of these will not. both of our examples did, but as you check it, if you see it on intersect once, double check, look around a little bit inside the graph, or if you're checking it on the solver app, make sure you're thorough with it. But if it does not, then we would just mark that as extraneous if it doesn't work. And one of them would be the answer, one would be extraneous. You don't have any of these on homework, but if you did have both come out extraneous, then it would just be no solution. Make sure you get on and do the 4 practice problems, and again, you must use the method of clearing fractions. No other method is acceptable.